Paper 2. Okay, a 30 ml aliquot of HCl was diluted. pH 2 is diluted to this. Water make following 3 ml aqueous. Determine the concentration of hydrogen ions in the original 30 ml aliquot. Had a pH of 2.0. So the 30 mils had 2.0. Alright, so hydrogen ion, this is not in your data booklet, this one. It's 10 to the minus pH. So that's 10 to the minus 2, so it's 0.01 moles of H plus. I don't know why they're asking you that. That's the one thing that's not in your data booklet. I don't know. All right. Hopefully everyone knows how to do that one. Calculate the final pH in 3 litres. Show your working. So the concentration, so the number of moles of H plus. I should do this without the scaffolding. That would be rather nasty. Number of moles of H plus is 0.01 moles, and so the final pH. So that's a concentration. Oops, that's molar. All right. Did I not check that properly? No, I didn't. All right. But I've checked it now after doing this. I would have corrected it in a normal exam. So, youch. So even though that is wrong, by default doing this would have corrected it. So I still get that mark. So that's the concentration. C equals N on V. I need to know the number of moles. And the number of moles is C times V, which equals 0.01 times 0.03. So that 0.01 times 0.03, 0.003, 1, 2, 3, 4, 0.03 moles. And so I know how that many moles of H plus. And the new volume is 3 litres. And so I divide that by 3, and I got 0.0001 molar H plus. So the pH equals negative log of the hydrogen ion concentration. You know, I'm not actually sure if this is the best way to do it because it does seem rather long. It's probably a better way to do it, but that's okay. I've done it now. Log. How do you do answer? Minus 4. So that's 4. It's a pH of 4. Determines the H plus concentration. Calculates pH. How did they do it? Dilution C1 V1. Yeah, they could do it that way. Don't like to do it that way unless it's a dilution. This is sort of a dilution, so that one's could have thought of doing it that way. That's quite okay. Don't do stoichiometry with that though. Question 2. Phenyl red is a weak acid that acts as an indicator as shown. Identify the conjugate base in phenyl red. It's always plus or minus a H plus. So really can't ask for more than that. Mark scheme. Iron. Yeah. Okay. Determine the dissociation constant Ka of phenyl red. So the data book's got the pKa, so it's doing a Ka to pK conversion. So you have to look up You have to find out where the indicators are, and then you have to do a conversion. All right, so fennel red has a pKa 7.9. So this is like pH. So pH is the negative log of the H, and the H ion concentration is 10 to the minus pH. So the Ka will equal 10 to the minus pKa, which equals 10 to the minus 7.9. You know, I only ever use calculators when I do these exams. So excuse me if I'm really bad at it. I've got to remember how to use it once a year. Where's 10? I don't know where it is. There it is. Oops. It's over there. 10 to the negative 7.9. Sorry. So K is 1 point. How many sig figs? 2. 1.3 by 10 to the minus 8. They've got the wrong sig figs. 7.9. That's wrong. It's 1.3. They've got the incorrect sig figs there. Okay. Next, explain the relationship between the pH range for fennel red and its pKa. The pH range for fennel red is 6.8 to 8.4, and that is 6.8. So that is from acidic, yellow, to basic, which would be red. Okay. And its pKa value. 4 marks. Chance of getting this correct are going to be low. Try and think of 8 things. All right, give me a moment, please. Acidic. So the more and more of this you take away, the more and more base that you add or remove this and turn it into the red. And so this will initially be yellow at around 6.8. This would be the 8.4. And it's pKa 7.9. All right. So at the pKa of 7.9, half is HIN yellow, and half is IN minus red. This is the point of the half equivalence value, half equivalence point in a titration, and where color change is most easily seen. I'm just going to write down everything I know. I don't know what they want. Explain the relationship between the pH of the color change for fennel red and its value. So when the pH is less than or equal to 6.8, it is mostly HIN, so appears more yellow. When the pH is greater than or equal to 8.4, there is mostly, even if it's just over 50%, mostly IN1, so appears more red. Okay, so the pH range is the plus or minus 1 pH value around, what is that, 7.9, 6.9 to 8.9. Where humans can determine there has been a color change. All right, I'm not going to go to write extra somewhere else. I'm just going to leave it at that. Sorry to be a bit flippant. 4 marks is a bit crazy. How did we go? Identifies color change occurs when they are equal. I did say that. Where did I say that? Half and half. Half and half. They better give that to me. I said it in a different way. Explains that when the phenol red equals H plus there pK equals pK. I said that with the half equivalence point. The color change is most easily seen. Identifies pH range color pK plus or minus 1. I did pH range plus or minus 1 value. Kind of said that. Explains the pH range of color changes occurs either side of the color change detected by. For me, that's sufficient. I haven't used concentration equals. I've said half is this and half of that, so they are equal. So it's all implied. It's just said in a different way. So I'm still giving myself 4 for that because I've done a full explanation. See, changes by 1. I've said when there's a 1 plus, so that's a factor of 1. Of 10 because it's 1 log value. So hopefully that doesn't, words to that effect is fine because I've said those in that effect. I just could have said it a slightly different way, which I might have had more room. Question 3. The concentrate pH and Kas of ethanoic and 2 unknown monos are shown. Compare the relative strength of an aqueous solution of acid 1. Relatively strength. So the same concentration. That one has a Ka, and so that one is 10 to the minus 5, and so that one is a smaller Ka, and so the Ka is products of reactants. So you've got going to a K plus. So if it's a smaller Ka, where are we? Then there'll be less dissociation. Weaker acid. Yeah, I'm not memorizing anything. I'm working it out. Okay. So you understand things in chemistry, you don't memorize them. So relative strength. So similarity. They are both weak acids with small Ka values. That's the compare the strengths. The difference, ethanoic acids is a weaker acid, slightly weaker acid than 1 due to a smaller Ka. What's the significance of that? It'll have CH3COOH as a weaker acid will dissociate into H pluses less, decrease electrical conductivity, higher pH, lower reactivity. I don't know, significance for what? It's a bit vague. Where's the mark scheme? Question 3. Sort of a question is that in the context of what? Must be pH. I don't know. Because pH is in there. Both weak acids, fine. It dissociates less to produce lower hydrogen ion. Less H plus. All right, it's a concentration. Would have been better to do that, but you can't really lose a mark for that. All right. God knows what they wanted for that. Just write a whole heap of things. Hope for the best. All right, 3-mark questions. Calculations are fine, but reasoning is panic mode. 6 things. Determine whether an aqueous solution of 1 or 2 would have a higher electrical conductivity. That's a really high. That's a strong acid. It's less concentrated too. So I need to keep that in view. I might do the reasoning first, and then tell you it's 2. All right. So acid 2, even though less concentrated than 1, so that's 0.1 molar compared to 0.2 molar, has a lower pH. So do the data as well with extra points. I'm looking for 6 things, right? 1, 2, 3, 4. So has a higher concentration of H plus ions. So is the stronger acid. Also, the Ka for 2 is high, greater than 1, 1.3 by 10 to the 6 compared to 2, which is 6.6 by 10 to the minus 4, which is less than 1. What am I looking at? This all confirms a greater number of ions in solution for 2, therefore more charge carriers and so higher electrical conductivity. All right, might be the best answer in the state. You gotta do an answer that good, please. All right. Differentiates the acid 2 is stronger than 1. Explains 2 distributes more hydrogen. Determines electron 2 will be greater. 2 will be greater than acid. What do we? It's a stronger acid, higher conductivity, produces more ions. Yeah, well, it truly said that. Can't be bothered reading it. Calculate the pH of 0.2 molar of K of this. All right. Always do a rice, whether you need to or not. Some mark schemes will ask for the rice, and you might not even need the rice. Okay, so always do the rice. So it's 1:1:1. You've got this as initial 0.2. You don't know what this is. This will change by x. Oh, sorry, plus. This will minus by x. 0.2 minus x. X and x. Most likely you have to make an assumption here, which equals x due to Ka being very small. Right, assumption in here, just in case the markers miss this. So the Ka, so doing all the proper setting out and working here, so I can't possibly lose a mark. Whereas anyone who skips steps, even though it may get you the right answer, is putting themselves at risk. X squared over 0.2, oops, what am I doing? And the Ka is 1.8 by 10 to the minus 5. So x equals 0.2 times 1.8 by 10 to the minus 5 and the square root of that. And unfortunately, my calculator needs to be able to deal with this. How did we do 10 to the minus 5 again? That one? Minus 5. Oh, that's log. Sorry. 1.8 times, I don't know what the best thing is to do here, 10 minus 5 equals, times by 2 equals, and then the square root symbol of the answer is that. Don't trust myself, I would do that again, but I'm not going to. All right, so what is the pH? So therefore the hydrogen ion concentration is that. So the pH equals negative log of that. Where are we? Log the answer. 2.72 sig figs. Technically, there's only two, or actually one sig fig. So it's actually 3, because it was sig figs. God knows what they're going to say. Oh, they did do it to the correct sig figs. What am I doing here? H3O says identifies the X equals concentration of that. What the hell are they doing? 1.82x. Well, I agree with that. That's nice. They don't round up there, which is wrong. You don't. There's calculation. There's round off errors. Why are they so bad at basic calculations? God knows. But they did get the right answer at the end, which surprises me. I didn't expect that. I expected them to write 2.7 or 2.72 and get the sig figs wrong. But they actually, they made it, they got it wrong, but they got it correct by accident by making an error somewhere else. So just do it the way I did it, because it's 10 times better than the mark scheme, okay? Question 4. Bioethanol can be synthesized from plants, amylase the number of plectin and starch, converted to glucose, and when fermented, all good. Explain the role of enzymes in converting amylase and amylopectin in starch to glucose. What is their role? For 2 marks. The role of enzymes. Without enzymes, starch is stable and would not break down. And break down slowly to undesirable compounds. This is not really part of your syllabus, is it? Enzymes speed up the reaction, also creating desirable compounds, i.e. glucose. They do this quickly, lowering activation energy, and increasing reaction rates. The problem is, I have no idea what they really want me to say. Just don't ask the question. Really? Well, you want me to say it breaks the glycosidic bonds? Identify the enzymes break glycosidic bonds in starch to form glycogen. Explain and convert starch to glucose by hydrolysis. What's the question they're asking? So they're looking for hydrolysis and glycosidic bonds. Explain the role of enzymes. Hydrolysis and breaking glycosidic bonds. Explain in the mechanism. It's really not about the enzymes. It's describe the reaction mechanism. I don't know. It's just I get 0 for that. They're describing where the bonds are broken and the reaction mechanism. So water comes in, so H2O goes in. And where the bond is broken. That's the reaction mechanism. That's not specifically enzymes are about lowering activation energy and increasing reaction rates. Damn. There's problems with the vague questions. I actually think I answered it properly, but I get it wrong. This is life. Just deal with it. Okay. Very last time. This is the old syllabus, and you have to have this memorized. If you make a mistake in the table, cancel out by ruling. No, don't redraw the whole table, and they probably won't mark it anyway, so ignore that. Just draw a nice line through it. So the monomers are alpha glucose in both ones. This is just memorization. There's nothing really to say here. It's glycosidic 1,4 alpha glucose. Glycosidic bonds. This is the 1,4 alpha glucose with 1,6 alpha glucose every 20 repeats. This is just your cheat sheet that you had to remember. So this is a linear polymer, and this one's branched. And so the shape, so they're just spirals. And this is more globular, which I don't know if you'd know because I sort of get that from proteins, but it's just branched, so they don't normally ask for shape. So if I just go to the answers, what if alpha glucose? They didn't ask for the repeats here. Not that I care because it's all memorized. Straight chain, branched, linear, same thing. Helix forms spheres. Globular is the better word. Many types of helices, so spirals, the same word. Can't be absolutely certain that they will see that because, as you can tell, I don't know the technical knowledge of the markers. All right, so I've studied these a lot because I did medical science, so I know the proper wording for those, and hopefully words to that effect I'll let them through, but who knows? All right, who knows? Determine whether the fermentation of glucose is a redox reaction. I need like I can't flip back and forth, so I'm just going to look at it on the other side. Glucose to bioethanol. I have to do the redox numbers to justify it. So C6H12O6 I'm going to leave out the balancing. Oops, I said I was going to leave out the balancing. Okay, got to be careful here. There's a lot of numbers. So there's -2, so that's a total of -4, so that's +4. That's a total of +6 and -2. So that must be a -4, -2. It's a -2, that's a -12, it's a +1, so it's a +12, so that must be a 0. So that is reduction, and that is 0 to +4 is oxidation. It's a redox as both reduction and oxidation are present. Carbon in glucose, oxidation number 0 to -2 when reacting to ethanol. Carbon in glucose, COSE, oxidation number 0 to +4 when reacting to CO2. 3 lines. It's 1, 2, 3, 4, 5, 6 type text. They want you to get in 3 lines. Reduction down there. Still did it, but gee. Atom economy. Yeehaw. Glucose bioethanol. That one to that one. So that one's not in your data booklet either. So it's what you want over the total times 100. And you've lost CO2 in this, so that's gone. So that's less than 100%. 100% is ideal. So it's going to be a calculator error issue, no doubt. So if I'm looking at the reaction on the other page, there's a 2 there, so it's carbon times 4, hydrogen times 6, oxygen times 2, and then carbon times 6, hydrogen times 10, and 12. Don't misread it. Oxygen times 6, that's glucose. So total was glucose, and this was ethanol. All right. Just double check those numbers. So that's 6 times 2, so that's 12. Oxygen's 1 times 2, carbon's 2 times 2. So 6, 12, 06. Your periodic table. Your periodic table's got hydrogen is 1.01, carbon is 12.01, oxygen is 16. So you got 3 sig figs. This is where it really helps to tell me the correct sig figs. This is actually 16.00. So I'm going to give 3 sig figs overall on this. And this is not going to be fun. 4 times 12.01 plus 12 times 1.01 plus, what's that? 2 times 16, 92.16. Chances of making a mistake here are really, really high. Typing in all these numbers and just double checking that you haven't made a tiny mistake is going to be disastrous for a lot of us, including me. I don't trust that, and I can't be bothered checking. Sorry, it's a practice test. If it was a real test, I would have to recheck everything, maybe redo the whole thing. Which they should allow time for, really, because it's only fair. So 51.1%, because it's 3 sig figs. God knows what they're going to say. I bet it's going to be wrong. That's all I can bet. Yep, 51. Calculates 180 over 92. Yeah, they're wrong again, kind of. Well, not if they stated to 2 sig figs, then they're right. Okay. Question 5. Galvanic cell. All right. Whatever. Describe the movement of electrons for 3 marks. You just make that a 1 mark multi-choice question. The movement of electrons. Q. Metal Q. What do we got? 2.5 volts. It's got to assume the electrons are going this way. And let's just double check that this is correct. So if the Q pluses are going into Q, that would mean the sodiums are going down. Yes. And then the MGs must be going to Mg2 plus. And that shoots the electrons up. And that would make sense for the chlorines to match the electrostatic charge. So the electrons, let's just start here. So this is the cathode and this is reduction. And this is the anode and oxidation. So magnesium is reduced to Mg2 plus at anode, releasing electrons that move through the wire to Q electrode, where Q is, oxidized, is reduced with Q plus ions accepting electrons to be Q solid. The electrostatic difference is neutralized by Na2 plus moving to QSO4 beaker and Cl minus ions moving to MgSO4 beaker. I don't know why. I'd rather they ask for products of electrolysis, because I've seen the syllabus, whereas this is just room to get things wrong for silly reasons. Okay, identifies magnesium electrode is oxidized, movement electrons through the wire, as Q lights are reduced. Well, I said all those and a lot more, and I'm not happy about it because I don't think it's proper chemistry. Where is the reaction? Where's the reaction with water? Where is the using the? They just never seem to do these proper reduction table calculations. Determine the half standard equation for the half cell and contains Q. So I hate flipping back and forth between these things. Determine the half equation and the standard electrode potential for the half cell that contains metal Q. Okay, only 4 lines. Where's the data booklet? So the total V equals 2.55, and we have magnesium going to Mg2 plus 2 electrons is something. So we just have to find the reduction table. Magnesium is minus 2.36 in the reverse, so that's plus. All right. So therefore Q is more than that. So Q must be 2.55 minus 2.36. And yeah, I don't trust myself that badly. I will do that on a calculator. 0.19 volts. And that would be for Q going to, it says so 4, so it's 2 plus, sorry. Ooh, and I'll correct that on the other page too, that I put plus, it's now 2 plus, okay. Sky, don't do that. 2 electrons plus goes to Q. Yeah, I don't mind that, but really it's not, it's not proper, like doing all the proper calculations. Determines half equation is this. Determine standard electrode, yeah. All right. Don't risk it. Put your states in, balancing, everything. Units, everything. Okay, identify one limitation associated with standard reduction potentials. One limitation associated with standard reduction potentials. Wow. Where do you want me to go with that? Associated with standard reduction potentials. One limitation, standard. Conditions are not easily done at standard conditions. Brackets including, if you look at the surface area on those, including surface area on electrodes. If I just have a quick look at the data booklet and reduction potential table, if I can find it, 298 Kelvin, so that's not too bad. I'm not quite sure where they want me to go with that. So again, it's a little bit of an annoying sort of thing to ask, really, when there's vagueness. All solutions must have a concentration of 1 mole, identifies a limitation. I identified the surface area is not correct. And why did they just pick on concentration and not all the rest? So I have to give myself a mark for that one. Maybe I should put example 298 Kelvin, some extra specifics. Although I did put 2 things down. I think that would get the mark. All right, determine whether metal Q is stronger reducing agent than metallic copper. Explain your reasoning. Okay, so reduction is the gain of electrons. Where's our standard reduction potential table? Where's copper? So we want copper fully reduced, so it's this one. So Cu2 plus 2 electrons goes to Cu solid, and that is plus 0.34. And copper, we had Q2 plus 2 electrons. It's going to Q plus 0.19. As copper has a higher E reading in the standard reduction table, it is a higher spontaneity, or it is more likely, just keep it simple, to reduce. Only 2 marks, there's 4 things there. What do we got? Determines Q stronger than reducing agent. Q's plus, I got those. Explains the lower standard reduction period is stronger reducing agent. That's gaining electrons, is reduction. So Q is less positive than copper. Yes, therefore Q is stronger reducing agent. Determines Q is a stronger reducing agent. Supposed to lower reduction potential. Reducing agent. Oh, ouch. I got caught out. Reduce, therefore oxidizing agent. That was nice and tricky. I got distracted by all the calculations. Therefore, I got this one wrong. I got tricked by the standard. That's a standard trick, guys. That trick is they always try and trick you on that, but usually multiple choice, only complex calculations. So I forgot the word agent there. So therefore, Q is most likely to oxidize, and the better reducing agent. Agent. Determines Q. No. I get a 0 for that because I got it wrong. Rather than QCA getting it wrong, which is often the case. All right. Okay, question 6. Make sure you've got your organic table thing memorized, and that doesn't matter if you're doing the new 2025 syllabus as well, because you still have to be able to answer questions like this. Okay. So it's all about memorizing, knowing that a carbonyl group's that. So 1 or 2. Identify a molecule that contains molecule 1. Molecule 1. Identify geometric isomer of 6. So that's trans. Of molecule 6. So you need to do the cis. What's that? Propene. 1 chloro. Prop. I like to say it. I like to put that in there. Wonder what they're going to say. 1. You can say chloropropene, but prop 1 they're probably just going to say cis, which is italicized, chloropropene, because it's assumed. What are we doing? Checking the answers. What do we got? 6A, molecule 1, cis 1 chloropropene. So they put the 1s there. Whatever. I prefer this one. Hopefully they'll let that through because there is a little bit of variation in that. Describe using a balanced equation a molecule 4 to 5. So you've added the H2s. Balanced chemical equation. So CH3. It's usually written like this. Relevant reagents. Plus, do I do that as a liquid or a gas? I don't know. Gonna have to guess it. You had to know it's platinum because it's just memorization. It's a CH3, CHNH2. It's easier just to have them as pure forms, and that would just be a gas running over it. Balanced chemical equation. That's balanced. All relevant reagents. We normally have heat in there as well. Let's put heat in there. All right. What do we got? Ooh, I didn't balance it. Did I not balance it? Ooh, NH2, and that's CH2, and I wrote that wrong as well. All right. I'm getting too careless. All right. Determines balance equation. Identifies appropriate catalyst. That's a horrible way to go out. Okay. Just be a bit more diligent than me, please. That was not good. All right. This one here is going to need me flipping back and forth. Okay. So molecule 3 is this. And then some sort of reaction halide. So there's 2 reactions you should know from that. And then reflux oxidizing alcohols. That's normally sort of a giveaway. So that will go to an aldehyde, then carboxylic acid. So if you look at these over here, that's must be molecule 2. So that's definitely molecule 2. And that's also getting oxidized. So oxidizing agent. So you got to fill in the gaps, right? Complete the diagram. So KMNO4 or potassium dichromate, but I'd have to check that out to make sure I didn't screw up the name for that with your data booklet. Okay, so that hydration, it's not in your syllabus. So they're adding water, obviously, to a double bond then to create that. And so this looks like classic Markovnikov, and that'll go to a ketone, and this will be a secondary alcohol. And so what they're trying to do there looks like they're trying to give you an alkene, but this is a primary. So primaries go to, with NaOH, go to alcohols, which is not what it's going to be, and then tertiaries get eliminated. This is what they're doing, elimination to alkenes. So they've screwed that up. They made a mistake. They love making mistakes on this. Who writes these? They do it like every single year. Go look at all the Markovnikov equations for the last 2-3 years, and they screw them up every single year for some weird reason. Okay, so you're removing that to create an alkene. So you're creating this name of product, and so Markovnikov's means you can add it to here, or you can add it to here. And so if you add it to there, you're going to create this thing instead. All right. So the UPAT name, and that's propene. And this will be propan-2-ol. And if you make that a ketone, it's going to be in the middle. So it'll be, yeah. So it's propan-2-one. All right, very confusing because they make those sort of mistakes, which is kind of difficult. So it is elimination, propan-2-ol. Oh, I didn't write the acid as well, and they should have accepted that one. Propanol molecule 2, molecule 1. Oh, molecule formed. So propan-2-one is actually molecule 1. So I get that wrong as well because I didn't write 1. I wrote the name of it. As you can see, I'm being pretty quick and careless. So that's actually only 3, even though I worked out the error and still managed to find out all the answers to everything. How's that only worth 5? 1, 2, 3, 4, 5, 6. Elimination, X, Y, identifies So I lose 1 mark for that. It doesn't matter. I still got 3, I think. I don't care actually. Whatever. 3, 4. So that's an issue. All right. But I should have still got everything correct. They're my mistakes. You should be able to see past QCA's mistakes. Okay. Okay. Question 7. Polylactic acid is biodegradable by. Ooh, this could be interesting. I did a video on this just by chance somewhere where I thought, oh, this is just obvious carboxylic acid here and alcohol. And that's the classic chemical, that's the polymer that's formed. And I think maybe it was a student's test or something. It's not actually hydrolysis or elimination or addition or anything. It's actually, it forms a ring and then it forms that and there's no additions at all. It's really quite unusual. I wonder if that's going to screw things up. Describes using the structural formula of lactic acid. So I don't even know what the answer to this one is. I would just, because it's not reasonable to know that. I just kind of knew that by chance. I would just assume this must be this. And the alcohol's stable, and that's where the weak acid thing is. So I'm just curious. Describe using a diagram. Describe. So I need to describe it and use a diagram. So I might just label this one up as a carboxylic acid. 1L, I think. That's an alcohol group. Therefore weak acid. I just don't know why it gets 2. And I know I've jumped a little. What have they given us? Describes the location of describes the, oh my god, so I did have to do that. I was just being overly cautious. God, I was. Described using a diagram. It doesn't say labeled diagram. Labeled diagram. Showing functional groups. I don't know. Sometimes it's just really vague and it's a little bit dangerous. So I just kind of fluked that. I got that from that, even though that is actually incorrect, but no one would actually know that. If you go research polylactic acid formation, you'll see it's not actually that. Water doesn't come off. So it's probably not a reasonable question that is related to its structure. How would you know that? Generally, it's these artificial halogenoalkanes that are highly unreactive with unreactive groups. So there's several things here, okay? Because the structure has open groups in them compared to hydrocarbon halides or CFCs. That can react it is more open to break down with enzymes. This is really a tough question. What makes it biodegradable, really? Because it comes from a natural source. This is the real answer. A natural source, a recognized biological common monomer, i.e. lactate, lactic acid. Many enzymes, many organisms will have enzymes. Because this polymer, because I've got to talk about the structure. PLA comes from a natural, so recognized. I'm going to use the word evolved, even though I disagree with that term, but that's a term that people will understand. Have evolved, and I think it's wrong, will have evolved enzymes. They wouldn't have, but that's what people think. Will have evolved enzymes to break it down. That's the real answer. I have no idea what the real answer is going to be. I actually don't care because I think it's so dumb. All right, polyic contains ester linkage. It explains that polyic contains an ester linkage. Explains that ester linkages can be hydrolyzed. Okay. Give myself 0 for this. Just tell me what sort of linkage does it have and how does that break? It can be hydrolyzed. Yeah. Okay. Yeah. I don't disagree with you. I just wasn't quite sure what you were trying to get at. Okay, I'll give myself 0 for that. Need to update our God mode. I think I've just been a bit slack. Name all the different types of bonds and possible reactions. Yeah, that's rough. Okay. Question 8, last question. In the aqueous solution, equilibrium exists. That one's yellow, that one's orange. Explain at the atomic level why no color changes once the solution is released to equilibrium. Wow, another worded question. Well, this is not an English exam. This is about chemistry. Where are all the calculations of actually getting things done, knowing what to use, what masses, and what the values are going to be? It's really weak. Okay, number one, it's just not really. Chemistry is about the numbers and the calculations. And because they've just littered it with little essays, it's easy to get it wrong, which is, as I've done the blog on before, the English is not chemistry. So the more English in here, the less chemistry there is. So definitely big thumbs down with all this English in here. Anyway, so we've got to do 4 things to try and get this mark. On the atomic level, why no color change occurs. So keep it to the atoms, or I should say molecular level. They can't even get the English correct themselves. Anyway, what are we doing here? So the forward and reverse reactions. State the obvious. It's a closed system, so this is not coming off. In a closed system, so none of the equilibrium can be established. This is God mode, guys. We've got to try and just state the obvious, because one of these marks might be something that's not in the question. As you can see already, if you've made it this far, congratulations. In a closed system, equilibrium will establish so that the forward and reverse reactions are taking place at the same rate. Haven't got to the atomic level yet. So CrO42 minus plus 2H plus will collide and react to form Cr2O72 minus plus H2O at the same rate as Cr2O72 minus plus H2O will collide to react and form CrO42 minus plus 2H plus. So the concentrations are constant of CrO42 minus and Cr2O72 minus. This is how I'm assuming this is atomic. are constant. So no net color change. One too many of these. What have we got? An identifies forward reaction equals reverse reaction equilibrium. Yeah. Explains the color remains constant because concentrations remain constant. So why did you emphasize atomic level? What the hell why did you even say that? I don't know, but I'm just glad to be done. All right. Tough work. All right.